We have example, find all zeros of f of x cubic plus 8x squared plus 11x minus 20. Rational roots theorem tells you list of possible rational roots or zeros of a given polynomial function. The possible rational roots are factors of the constant. So factors of the constant is here. We take all the factors of this constant and we divide it by the factors of leading coefficient, which leading coefficient is here 1. And to find all the factors of the 20 can be plus minus 1. Those are possible. Plus minus 1, plus minus 2, plus minus 4, because 4 is a factor of 20, plus minus 4. Then can be plus minus 5, because 4 times 5 is 20, so 5 is a factor. Plus minus 10, 10 times 2 is 20, so 10 is another factor. Plus minus 10, and 20. 20 times 1 is a factor, so it's plus minus 20. So those are the factors of the constant. Factors of the leading coefficient is 1 is here, is just plus minus 1. But possible rational roots are if we divide those factors by the leading coefficient. But because leading coefficient is just plus minus 1, if we divide all these factors here, we are going to get to the same value. So I'm not rewriting here. And how many are possible rational zeros? It can be plus minus 1, can be plus minus 2, plus minus 4. So it means 2, 4, 6, 8, 10, 12. There are 12 possible rational roots. Doesn't mean all of them are, but it can be from this 12, 1 or 3 of them. So is a 12. So the number is 12. So now, if we want, we have to check. The one way we can check a factor theorem. For example, if we take in f of 1, f of 2, and we are plugging here, if it gives us 0, it means that one is a solution, or in other words, there is one of the factors. For example, if we are trying with the first one, if we are lucky, we get the right away. If we are not lucky, we have to check all of them until we get to the rational. It can be any number of them. But because here we are 1, let's try with the 1. So f of 1 here, and we can try it. F of 1 is equal. So here is 1 cubic plus 8 times, instead of the x, I'm plugging here 1 square. 1 square plus 11 times 1, instead of the x, I'm plugging 1 times 1, and is minus 20. But if we are working here, this is 1. So let me add 8 times 1 is 8, plus 11 times 1 is 11, and minus 20. If we are adding all together, 1 plus 8 is a 9, plus 11, 20, minus 20 is 0. So this is a 0 or a rational root of the polynomial function f of x. In other way, you can check by synthetic division. By synthetic division, you can check them. Whichever way you think is easy. But synthetic division, again, you have to get the remainder 0. So it satisfies the factor theorem too, even here. But now let's go and find one of the factors here, because now I need to find the other factor, the quadratic. Because it's a cubic, I need the quadratic factor. One linear factor, I can find it, is because it's 1, is x minus 1 is opposite side, is the factor of the solution. So here, let me write here a coefficient. Here the coefficient is 1, then is 8, 11, and is minus 20 here, okay? So I have all in the order, third, second, 1, and 0. If I'm looking at the degree, none of them is missing, so I just can plug in here. And now here, the first number according to synthetic division, I am dropping down. 1 times 1 is 1. So I'm writing here. 8 plus 1 is 9. So this is 9. And 1 times 9 is 9. I write here 9. 11 plus 9 is 20. And 1 times 20 is 20. And minus 20 plus 20 is 0. So it satisfies this 0, it tells me the x minus 1 is a factor. But now here I'm looking, because it's x cubic, so this can be x squared, 1 degree less, because I divided by a linear factor. And here is minus 9x plus 20. So this is a second factor. But as I saw here, as we see here, in this example, we already see 1 is a solution. So it means that x is equal with 1 is one solution. So let me write here one solution. X is equal with 1. And let me look for the other solutions. And now if I want to factor this here, I can factor 20, and I needed to find this minus 9 here. This, I'm sorry, this is a plus 9 here. This is a plus 9 because 8 plus 1 is 9. It's not a minus. I need to find here plus 9. The good factors here, 5 and 4. 5 and 4. Okay. Plus 5 times plus 4 is plus 20. If I multiply. Plus 5 plus 4 is a plus 9. So it satisfies this condition. So this I can factorize in x plus 5 times x plus 4. So I can factorize. X plus 4 is equal to 0. And now if I'm looking for solution of x plus 5, here solution is minus 5, so it's opposite of the factor. Or I can apply the zero property, zero product property, and I can find those values. But I'm taking here shortcut. I'm taking the opposite of what is the factor. The solution is x minus 4. So already I found the solution. 1x is equal with a minus 1. 1x is equal with 1. Other x is equal with minus 5. So we found all three solutions. And the last solution is x is equal with minus 4.